This video is going to talk you through energy stores and systems. So the first thing you need to know are all the different types of energy. So the first type of energy is kinetic. That is energy from anything that is moving. The second type of energy is thermal. That's obviously energy from anything that is giving off heat. The next type of energy is chemical energy. So that's energy that is stored energy. So that comes from things like batteries and fuels and even food, all of that as chemical energy. The next one is gravitational potential energy. That's energy gained when something is lifted up high. The next one is elastic potential energy. That's obviously energy in elastic bands and springs and things like that. And these are all your energy stores. So what that means is when we're talking about energy moving from one store to another, these things can decrease and increase their energy stores. Now the other types of energy that you need to know about are electrical energy, sound energy, and light energy, along with nuclear energy. Now these aren't stores. So when we're talking about energy changes, you wouldn't say that these things would increase or decrease, you would just say that energy would move from electrical energy to light energy, for example. So the first thing is making sure that we're aware of all of these different types of energies. Now the next thing that you need to know is how energies transfer from one thing to the next. Now a really key principle in science is that energy is not created or destroyed, it's only transferred from one form to the next. So for example, if we pick a light bulb. Now light bulbs work because you have electrical energy, and we would call this the input energy, and it is transferred to light energy. This is called the useful energy. Now, as well as the light energy, there is also heat energy produced as well. Now, this is wasted energy. This is energy that is not wanted, but is produced as a side effect when the electrical energy gets transferred to light and heat energy. Wasted energy usually comes in the form of heat, and what happens is it heats the surrounding areas. So that's an example of a simple energy change. You've got electrical energy going to light energy and heat energy. And the heat energy is used to heat the surrounding areas. Now if we pick a slightly more confusing one now, if we look at, say, for example, a roller coaster, and the energy change is involved in a roller coaster. Well, a roller coaster is going to look something like this. And here is my roller coaster. Obviously the roller coaster is going to go up to the top of the track. So what are the energy changes involved? Well, first of all, we've got electrical energy. Same thing again. However, this time that electrical energy is going to be transferred into kinetic energy because obviously the roller coaster has got to move to the top of the track. That kinetic energy, then because it's going up, it's off the ground, is going to be transferred to gravitational potential energy. So we can see now we've got multiple things happening. Now in here though, that electrical energy is also going to be transferred as heat energy as well. Remember, this is our waste energy. This is not something that we want. Ideally, all of the input electrical energy would be transferred to kinetic, and that kinetic would be then transferred to gravitational potential. That's in an ideal world though. Now, because this heat is produced, not all of that energy is transferred from one form to another. Now there is a way that we can reduce this heat energy. This heat energy can be reduced with something called a lubricant. So a lubricant is basically there to reduce friction. It's the friction between the wheels and the track that's causing this heat energy. Now there's a really easy way to visualize this. If you take your hands and you rub your hands together really fast, what you'll notice is that your hands will get really warm. That's because of the friction being produced. If you take a lubricant, for example though, I've just got some soap, rub it on your hand, you'll notice that your hands will be really slippy. There won't be any of that heat produced, and therefore we've managed to reduce this heat. So therefore, more of this useful energy will be transferred to, more of this input energy will be transferred to the useful energy, sorry. So that's one way that we can reduce our wasted energy, is through the use of a lubricant. Now that obviously wouldn't work with something like a light bulb because there's no moving parts, but anytime you've got moving parts, a lubricant can be used to reduce that friction and therefore reduce that wasted energy. Okay, another thing that we need to be aware of how the stores of energy can change. So for example, if we take something like a remote control car, and you will have to just mind my drawing. So imagine that this is an RC car, remote control car. Think about the energy changes involved in there. Well, we've got chemical energy from inside the battery, and that's going to be transferred into kinetic energy when the car is moving. Now, obviously, with most things that's got moving parts, there's also going to be heat energy there as well that's wasted. And that's going to obviously come from the friction between the wheels and the floor, and obviously the moving parts that are inside the car as well. Now, we could talk about this energy transfer in terms of the stores of energy. So what we would say is that the store of chemical energy would decrease, and the stores of heat energy would increase. So we've talked about the changes in the stores between one decreasing and one increasing. So it's just another thing you've got to be aware of as well. Anytime that you've got those energy stores that we talked about initially, anytime that you've got one of those things transferring from one to another, if it's a store of energy, then we need to just make sure that we're being consistent with our wordings and things. The final way that you could be asked to do something like that as well is, for example, in a furnace. So furnaces work, and apologies, this is supposed to be fire. Probably better that I write fire on there. For example, if you've got things like fire in a furnace, then obviously what we would say there is fire is a fuel. So that's chemical energy again. So what would be happening here is that the chemical store would be decreasing, and the thermal store would be increasing. So as the fuel is being burnt, the stores of chemical energy are decreasing, the stores of thermal energy are increasing. And that's everything for today.